So happy to see so many of you here. I sincerely hope you'll learn something today, even if you are experienced with Unreal Engine. And the idea today is not to necessarily go into super in-depth about specific segments in Unreal Engine, but explain in a certain degree what Unreal Engine is, what you can do with it, what it's about, and then create something very simple from start to finish. That's going to be the agenda. And if you ever have questions throughout the lecture, please raise your hand or just shout out. I mean, I encourage if you have any questions. Anyone is welcome to participate. So Unreal Engine 5, this is going to be an hour long, by the way. And if you feel like you want beer, but you want to be tactful about it, don't worry. Just go up and get a beer. It's fine. So Unreal Engine 5, what is Unreal Engine to begin with? So literally what it says on the website, and I'm going to explain in detail what this means. It's the most powerful real-time 3D application. And what it means by creating 3D, we all have heard of CGI, what it means. We can create video games, we can create cinematics, anything you want to visualize, but you can also create 2D games, VR applications, AR applications, but its main core, its main selling feature is 3D application games. So the agenda just laid out quickly again. What we're going to do, we're going to be focusing on game development, even though in Unreal Engine you can do a lot of different things. But we're just going to focus on game development. And I want to briefly go through like a short history of the engine, and we're going to look at why Unreal Engine 5 specifically is such a significant leap in the history of the engine. And we're also going to explore Blueprint, which is the choice of language when it comes to programming logic in Unreal Engine, which is basically, we'll get to that actually. And then we're going to create something very simple from scratch, so you can see the process, because for instance, in Pluralsight, a website similar to Pluralsight, you always get this, or sometimes a lecture where the lecturer will just copy-paste a bunch of code and say, go along with this works, and then we continue onwards. I want to show when we launch the application until we run the game. Something very simple. That's the main goal. And by the way, I also dislike when lecturers always interrupt with questions. So I'm going to ask this once, or rather 3 questions in succession. Who is familiar with Unreal Engine? Nice. And who has actually used Unreal Engine? That's it?
For playing or for building?
Building, yeah. And I think this will generate more hands, but who likes games in general? Who plays video games? Yeah, we're all interested, right? So hopefully you'll be interested in delving into this application in the future. Or if I've done a bad job, you won't touch this again. Hopefully not. So brief history. Unreal Engine is actually an application owned by Epic Games. Epic Games is the company behind Fortnite. You may know this game. And it is essentially what I described in the past, so a 3D computer engine where you can create cinematics, game development, AR, VR content. And it was actually first showcased, I think it was in development from 1995 or something, but it was first showcased to the public, released to the public in 1998, with the game literally called Unreal, which is the first image. And then actually, because you may have heard of the news, Unreal Engine 5 is quite big news, and it actually released in conjunction with the Matrix demo from this year. So you can see quite the leap, and it's actually not been in development for that long. So the 5th edition was actually released in April this year. And it's used in a variety of industries, like I mentioned, video games, the movie industry, and like a simple example that I found actually online was, imagine if you're purchasing real estate and you want to see the fastighet, or like the property. Yeah, thank you. When you want to see the property, but a lot of companies showcase them before they're actually built. And a lot of companies actually use Unreal Engine to actually showcase this. It's really cool. So let's talk about, and yeah, I'm going to split this lecture. So 30 minutes probably talk, and then 30 minutes Unreal Engine. So the 5 in Unreal Engine, like what is the significant leap in the engine's history? So with those with maybe OCD might notice that I have 4 keynote points. Probably should have had 5. But the big one is nanites. Now, I'm not an expert in game development from the core, creating game engines at all. But nanites is essentially, so the thing about computer graphics is any object you want to model is basically comprised of something called polygons. These are geometrical shapes. And you have planes of them, so an object will comprise multiple polygons. And imagine if I'm standing here and looking at an object very far away. What the computer used to do in past iterations of the engine, and what other game engines do, is that they will actually render less polygons far away. Because you're not interested in high graphics far away, otherwise it's going to consume a lot of computing power. And when you're close up to an object, you want to render as many polygons as possible. That means the picture is crisp and it's not blurry. And the difference now is there's something called nanites, which is specifically in Unreal Engine. And it basically means that instead of computing how many polygons to display, because there's a thing called let's see if I remember the word, level of detail, LOD. That signifies how many polygons we want to showcase in an object to represent this object in the game. And when you have an object far away, there's going to be a lower level of detail, LOD, which means less polygons. But you have to compute this rendering, and that's why it can be slow. And you get these in games, I'm missing the word, but when things materialize out of nothing, you get this rendering issue. Nanites can do this in real time. That's a big leap. You don't need to compute. It can just render it on the go in real time, which is really cool. Another thing, and that's the first image, by the way. So you can see actually how nanites are comprised of these polygons, and you can render them in real time. When it comes to Lumen, this is another big leap. So for those who are interested in gaming, there's always been a struggle with global illumination, the way light bounces off of surfaces. And Lumen is a way to tackle this, which is something new to Unreal Engine 5. And in the past, what they used to do, so imagine if I move a lamp in this area, for instance. The light needs to reflect the bouncing. Like the light, the way it bounces or emits reflections needs to be calculated in real time. In games, they used to fake this, or at least in Unreal Engine previous editions. So they would fake this by pre-calculating the position and then applying a texture. So it's actually a texture you're seeing. You're not seeing it in real time. And what Lumen does is it calculates it, again like nanites, in real time. So it calculates how is the light bouncing off of the surface of an object in real time. And Lumen is actually based on ray tracing. But the difference is, you may have heard of ray tracing with graphics card, NVIDIA. It's very common. But the problem with ray tracing is it requires a really powerful GPU for it to work. And games need to enable it as well. Lumen is actually based on ray tracing, and I actually read an article about this, like the actual kind of like physics or like the actual engineering behind ray tracing is pretty phenomenal. But I'm not qualified to speak on it. But yeah, it's based on ray tracing, but it solves it in a way that computes less power for the computer, which means you can, yeah, go ahead.
So when you say, if you don't know, I do understand that, but that's really wrong. Anyhow, when you say it's based on ray tracing, and as you said, the GPUs usually done that, at least in NVIDIA's, is this more placed on the CPU now when it's in the game engine, or?
Oh, when it comes to the hardware, the honest answer is I don't know. It should be on the GPU, because the thing is, the way it calculates, the way this lamp would move, where's the light now bouncing off? I'm not sure how it does it. Like you would go into the core of the engine, but it does it in a better way than what exists now. But good question. The third feature is metahumans. So you can actually play around with this. You don't need Unreal Engine on your computer. You can actually just launch a browser, go to the website, and you can actually play around with this. So it's a way to create hyper-realistic human characters. And I think for those who have iPhones, you can actually scan your face import it to Unreal Engine, or sorry, import it to MetaHumans, and then import it to your game. In Unreal Engine, you can actually pay your playable character, and it will look like you. But yeah, the interesting thing is this is not integrated in Unreal Engine. Instead, like I said, it's just a website, and the rendering is occurring in the cloud. So not on the computer level. And the last thing I want to mention is megascans. So if you're not an artist, this is great for you because megascans is a library or compiled by a company called Quixel, like an indie company, that Epic Games acquired in 2019. And what megascans is basically, what it contains is something called, and this is again beyond this lecture, something called photogrammetry assets. Photogrammetry essentially means you take high definition or high fidelity pictures of environment surfaces, you import it, or you use a special camera, import it, and then create a digital asset out of it. So you can reuse it. And the thing is, Epic Games did so well with Fortnite and other games that they actually acquired the company and made megascans publicly available to anyone that wants to use it. So we're going to have a look at that, what the assets involve. But you can get textures, 3D objects, plants, like anything. And they actually went to different locations like Japan and other places, took real life photos, and then imported them. So you can create, if you want, feudal Japan in your own game with metahumans, maybe yourself as a character. So let's get to maybe something more interesting for developers. I assume most of us are developers here. So Blueprint is the native language choice in Unreal Engine. And Blueprint is actually a visual scripting language. So imagine if you're working with JavaScript, for instance, you're working with text-based code when you declare variables, functions, whatever. Blueprint is different in the sense that it uses node, like a node-based system. So it creates nodes and it compiles a network. And that's the flow. We're going to have a look at this. So if this doesn't make sense yet, we're going to have a look at that. So yeah, it emulates text-based programming. Hence, many familiar concepts that we might know of are in here. So the thing is, I put is with a slight, like a marking. It doesn't say specifically that Blueprint is an object-oriented programming language. But the way I've used it, it seems like it, and it actually supports classes in an object-oriented fashion. And game development is very common to use, OOP methodology. So yeah, we're going to have a look at this. And you may be wondering, so what am I actually programming in when it comes to Unreal Engine? What languages am I using? You're using two choices. Blueprint, which is this visual scripting language, and you're using C++. And you can actually either use one of them, either or you can actually use both as a mix. And I might show it. I've done it a little bit where you can use VS Code to compile your C++. You create binaries and you can load them into Unreal Engine. Actually, yeah, the live coding is just a way for you to be able to code C++ and then build the binaries, then import them into Unreal Engine. So I hope it's not, I feel like maybe too much text, but bear with me. So what is Blueprint actually? So we're going to discuss a little bit about the nodes because that forms the cogwheel in this huge machinery. So you can think of nodes as pre-made functionality, like a function, like say an audio clip. You can think of basically anything you do in general programming. And nodes can also represent variables, functions, classes, and structs even if you've used OOP languages in the past. And we're going to have a look at what this actually means, the pins. But if you think of a Blueprint node, this is a node, and this is like the network of nodes, which comprises like an application. So if you have a lot of JavaScript code, this might comprise one function, or this might just comprise like, I don't know, clear list or something. And so you have two pins that are important to keep note of. These two first pins, these are the execution pins. The first one on the left will tell you when to initiate something, when to run a node. The other one is a consequence of running that node, what happens afterwards. The secondary nodes, these two, essentially, or at least the ones with the colors, represent the data pins. What data are you actually passing into this node, and what functionality will be executed. And you can have arguments and return values. So let's actually do something more fun, which is actually create something basic. And, oh, I didn't mean to put that there. Oh, actually, that was a bad joke. Let's see. So we're going to boot up Unreal. And this is intentional, so we're going to hopefully not get mishaps. But the idea is that you can see me launch the application from the get-go, and then we'll create something super simple. And what we're going to basically hopefully create, I really thought about this ahead of the lecture, like what's something very simple we can do. And I thought maybe it's a very trivial example of using this engine, but we're essentially going to create a little maze, and you're going to run through it. And maybe we'll add some logic like, yeah, this will be a bit on the fly. But the important thing is we'll get familiar with the editor itself. We'll have a look at creating a very basic level with very simple lighting. And we'll be importing some assets as well, so we can see what actually the marketplace looks like. And then we'll be implementing some logic using Blueprint, and then we'll run the game. Do I have any questions in the meantime? I need to have some water. No?
I got one. Hi. Nanites. Is that an invention by Unreal, the team behind Unreal Engine? Or?
Yeah, my understanding is that yes, it's entirely exclusive to Unreal Engine. But you can think of like the implementation uses fundamentals based, like agnostic fundamentals. Like anyone can create an implementation of this. So they're using techniques that have existed in the past, but Nanite is a solution to implement this.
Okay.
So yeah, I don't know if that makes sense, but like ray tracing in Lumen. Ray tracing is one implementation of using ray tracing, and like you can literally look this up on Wikipedia. It's super complicated, like how they reflect light and everything. Ray tracing is a way to fix this in games, or they use ray tracing in NVIDIA supported GPUs, or NVIDIA GPUs mostly. Lumen is just another way to actually use ray tracing also to solve it in a little more efficient way.
Okay.
So same with nanites, it's just a different way to solve something. So because we're not going to create a third-person character from start, this is what it looks like, by the way, when you launch it the first time. And I recommend you try this out because it's so simple to just get started. So like I said, we have film, video, events, architecture. We have a bunch of different things. But we're going to start with a game template and then build upon it. And we're actually going to use the third-person template just because we want the character. That's the only reason why we're creating this. And you can choose between C++, we'll choose Blueprint, desktop maximum. Starter content just means basically that we'll get a bunch of free assets, but it will take longer to actually load up or boot up the project. We can call this demo land or something. And we're going to disable ray tracing. So we're going to create the project. So this is what we're greeted with the first time. And one thing to note is the settings might look, or the level of detail might look a bit rough. And it's because I'm using a Mac. A Mac is not recommended in general with Unreal. It's not really well supported. If you have a high-end PC, use that instead. So I've just scaled back all my settings to low in this case, in order, otherwise it would like really like lag a lot. So this is the editor. Like the important thing to note here is we have, I would say like 3 different things to take note of. We have the actual viewport, what the game will actually look like when you import the assets and just play your character. We will have like similar in Photoshop if you ever used it, like details pane, and if you click certain items, you'll get a bunch of details. So it's very similar if you've used Photoshop in the past. And then we have like a file explorer, which is the content drawer. You can dock it if you want, but this is basically where all your files will live. And the basics that we have here is actually from the starter content, or actually the template that we used, third-person character. And this is actually a third-person blueprint, and I'm going to discuss the blueprint layout as well. But if we just try this real quickly, just see what it looks like. We can play the game, and this is what it looks like. Nothing special. But the idea was that we create a new level. So we'll actually be creating a new level. We have some choices here. I'm just going to choose an empty level because we want to start from scratch. And I said, simple lighting for now. So we get nothing. I think you can see the grid. Yeah. So the landscape will give us a basic template. And I'm actually going to minimize this. So I'm going to, it's hard to see here exactly, but let's just do 1 by 64, I think. So usually I just keep the defaults, and then we create this. So now we actually don't have any lights, and we actually have different perspectives. So we can see different, like how the engine views this. We can see the wireframe. It's going to look a bit different. It's going to look way different when we add some content. The unlit version, the lit version. Right now we don't have any lighting, and I can't see anything. So we'll start by adding some lighting, actually.
So what would happen if you started the game?
Shall we try? Let's do it. Because the plane should exist at least.
Okay.
Yeah. Because the thing is, we have a plane. You got me way excited with that question.
Sorry.
But it's
excited too. That's fine.
But it's good. So it breaks the monotony of just speaking. So actually, let's keep this unlit for now. And let's start adding lighting. So we'll add a... yeah, go ahead.
So the player character is completely separate from the level then, because it appears to be the same player character there.
Yeah.
So creating a new level is not the same as creating a new game then?
No. So when you create different levels, you can actually, like imagine if you have loading screens, like you would say boot up this loading or level. But the character is always the same. And if you're interested, like how can we control where it starts? You can either right-click and say play from here. And we see this character nowhere. But you also have this player start functionality, so it's this one. And we can drag this anywhere we want, so it's the player start. And it's over there now, so if I move my camera over here and play the game, yeah, I'll start here. And take my word for it, we're actually in the correct place. So let's create some lighting. So we'll need directional light, which designates where the sun should strike, or the direction of the light. And by the way, when you use Unreal Engine, by the way, I'm going to save this map as well. I don't know. And we'll also add a sky as well. Now you only need like 4 things, and then you have pretty much a game. So we'll add an atmosphere. I'm going to put this to lit. So we can already see we have the atmosphere. And I forget the shortcut, but you can actually use, rotate the directional light. If we have a look at the directional light, this is the component here. Let's see if I can find it. Yeah, for some reason it's hidden. Oh, I realized that I was still on landscape mode. So I'm on select mode now. I just want to show you some of the basics controls. So even if you're making a 2D game, this is what I learned like the hard way. Like there's no 2D mode to create video games in Unreal Engine. You literally fake it. So you create something in 3D, but the camera looks in a way so that it looks like it's 2D, which is a bit of a shame. So, so we have 3 basic controls, X, Y, Z, since we're in a 3D or place. And yeah, it's really laggy for me a bit. But yeah, basically 3 inputs that are important. You have the direction that you're interested in moving it. You have the rotation as well. And there is a shortcut to make this more easier to control. But if you see, if I point the sun to point upwards, we're not going to see anything, obviously. So let me adjust that. And then we have the scaling as well. I'm not actually sure what it will do with the lighting. I don't think it will do anything. But yeah, let's move on. So let's add also some clouds. So you see we have some clouds. So this is how simple it is. And you see this black background. And we can actually hide that using exponential height fog. So yeah. And then you would kind of design it to include things, but we're going to keep it simple and we're going to move on. And you see this indentation, it's because I had landscape mode on, and you have like a brush element, so you see this. But we're not going to do that. So to keep this moving forward, I'm just going to add one quick setting. And we're actually going to just set the default maps to demo land, the new one. So anytime you open the editor, it's going to default to this. That's it. And we have a player start as well. So we set to create a maze, right? So this very simple game will just be like a box. You will enter a door, some music will play. You exit, and you'll be greeted with like a sign, you made it, or something simple. So there is actually something called, I think that's pretty new also. I think it's called like geometrical brush, shape brush or something, GSB. And let's see if we can get this. So I'm going to add a cube here. And I realized that my landscape, unfortunately, is dented. But let's see if we can fix this. Does it move at all? Really hard to see this cube. Let's see. So essentially what I'm going to do is, yeah, for some reason I'm not seeing the actual outline when I drag this. All I want to create is a simple like place where you enter so we can exit it as well. And soon we'll talk about Blueprint as well, which is a bit cooler. It's a lot easier when you actually play around with a ultra wide screen than this. So I've added this huge box. I'm actually going to copy paste this box. And then I'm going to use something called, you can actually do a subtraction of this cube. And we're actually going to modify the scale and say that maybe this is 24 by 24 by, actually we'll keep it like this. So it just basically creates this. And we're going to create quickly 2 doors as well. So I'm just going to drag a new box. You can rename these files as well. And let's actually just modify this door a bit. So I should mention, by the way, if you're an artist, like innately an artist, you'll have a lot easier time migrating over to Unreal, especially now that they've introduced Blueprint. So we're going to have a look at that soon. But if you're a pure developer, it's going to be much harder. Which is like an uncomfortable truth, but it's really difficult with game design. Like you can see, this is not the most beautiful thing. So let's subtract. So we have our simple door. We're going to copy paste this, and we're just going to drag this to the other side. I'm going to do this a bit quick, just so that we have something. And I'm going to modify the player start to start outside of the first door. And let's see where it is. So now if we play the game, we'll start outside of our door, but we wanted to create a maze. So let's do that super quickly. I'm going to escape out of the brush method and just use basic cubes here. There is a better way to create mazes, but this is like the short version of it. This is really hard to see a good look at. So the reason why I'm doing this, let's actually just move this. So with Option, if you hold down Option, you can just copy paste this, and I'm just going to add a bunch of these, like this. So bear with me, we're almost done with like the basic modeling of the map.
Did this inspire Minecraft at all?
No. I hope not. So I'm just going to copy paste all of these and then actually do the same thing. See if we can get this to move. And then I'm actually going to copy paste and do a rotation 90 degrees. And then we're actually going to move this like this, and maybe like that. So like I said, like the world's worst, simple game. Still running with that joke. So I think this will be fine. It's not, like I said, it's very basic, but if we start, so now that we have our basic maze layout, we can just remove certain items and actually start creating this little maze wars. It's really hard from here. And has anyone heard of the right-hand rule when it comes to mazes?
If you follow the right hand, eventually it will go.
Yes. I actually realized I clicked on the floor. That's probably, we probably want to keep that.
Does that work? Like if you go to the right?
Sorry?
So just follow the wall all the way. Eventually you get to the end of it.
You do actually work with the left as well.
I don't know.
So if we wanted to, we could, like, I've literally just created like a straight path now. Oh. So if we start playing our game, super basic. And let's have a look at, because I don't want to drag this out for too long. Let's actually have a look at Blueprint. That's the exciting part. This is super basic. Blueprint, essentially, like I mentioned, is a visual scripting language. If we have a look at our Blueprint character, and the convention is to have BP underscore, that means Blueprint. And like I mentioned, so these are the defaults that you get from a game, from the third-person character. And the node-based system is, so this is a custom event. We can see, you'll learn to recognize like different color patterns. And they always have a designation. So red means event. I think it means Boolean when it comes to data types. And you have the execution pin. So what happens after the event is invoked? What should occur afterwards? So it's going to run this node, and it's going to rely on this data pin. And the green, I don't remember exactly what green was. That's a float value. So what we'll do for now, just a super basic thing, we'll start with the level blueprint. So a level has a blueprint as well. And I said we're going to make the, what do you call it, the maze runner. So I think we should have some music for that. And what you can do is you can right-click, and you get this context menu. And essentially, this just lets you know all the functionality, all the pre-made nodes you can choose from. And every game or every level has this begin play. And I'll show briefly. So when we create a blueprint, we have three different things. We have the viewport. This is essentially your character, and you can see the camera, you can see the capsule as well. This is the hitbox of the character, so when something collides with it, you can make something happen. You have the camera as well. And when it comes to the construction, I forgot what this is called, construction script. This is anything that runs before the game actually runs. And when the game is running, all of this will be occurring. But we're working on the level blueprint. We have the event begin play. So, yeah? Any question? No? When it begins playing the game, we're actually going to play a 2D sound. And I mentioned that we have our file explorer. So I'm just going to import, actually downloaded this earlier. So we're going to import to the game this maze running music. I'm not sure if we're going to hear it, but we'll see. So I'm going to choose it. And then we're going to play the game. Do you hear something? No? It's using Microsoft speakers. This might be loud, I'm not sure. And you see I'm using the lowest resolution. You see how laggy it can be. Oh, I never actually put them in. So let me change that to Mac. But yeah, and we said, so we're going to reach the end, and we actually want, yeah? This one?
No, okay, sorry.
Oops.
No, sorry. That was there. Just kidding.
Oh,
Just kidding.
I realize I've been standing on this puddle of water for a while. So we're doing this real on the fly. You can see I lost the floor, or actually it's below, yeah. So let's create our first blueprint, actually, just to illustrate how this works. And we can actually, so we're not going to use this. I just want to illustrate how we can use blueprint to create characters, design, etc. So we have different components here. Actor is, for instance, any static meshes, any static objects in the game. And you have pawns and characters. I believe the difference was pawns are the players, and characters are like NPCs and stuff. So we can call this like BP, what could we call this? I don't know, key or something. So now we're going to open this blueprint editor, and this is where we get familiar with blueprint as a whole. So I mentioned we have a viewport. We have nothing there. We have the construction script. Anything that occurs before the game is running will happen here. This is when you want to load assets and stuff. We have also the event graphs. This is where we'll add our logic. So for now, let's make something simple. First of all, we need a static mesh. And I want to show you the library real quick. So in our content drawer, let's actually import. If I can get, oh. So I mentioned Quixel, right? Oh, we need a plugin web browser. Oh, there's one, yeah.
I have a question. So you said that there's like a bank of characters and stuff. Can you get like different like textures and stuff from there too? Like,
From Quixel?
yeah. Can you get like different textures? Is that like save? Can you like use it?
Hey, yeah, for sure. I'm going to show the marketplace. You can get textures, you can get assets, objects that you want to use in the map.
And if you make them, can you like upload them
To,
for other people's use?
I don't know about Quixel, because it's like a private or like a subsidiary of Epic Games. But you can add your stuff to the marketplace in Unreal,
You could make your own place as NPC.
and you could sell it. Yeah.
For people to use in their games.
I like the way you're thinking. Yeah, actually, yeah. So just to illustrate, if we look at the marketplace, let me bring up the content drawer. Not sure, yeah. So we have add Quixel content. This is not the same as the marketplace. So this is the Quixel bridge that I mentioned, like these hyper-realistic photogrammetry assets. And we can actually, just to try this on, just to see how we can import this. That's really laggy for me. We take surfaces. That's just anything, historical, this one. Oh, I need to sign in. Yeah, let's skip that.
Are these free to use?
Yeah, completely free. So Unreal bought this company, and you have 16,000 assets that you can use. But I'm actually going to add, see, where did we add that? Yeah, I guess I'll go through Epic Games Launcher. I just want to show it. So there's two things. Quixel Bridge, where you get assets that are hyper-realistic. And then you have the Unreal Engine library, like a marketplace. Like think of the App Store. So we have Unreal Engine. We have the marketplace. And yeah, you can get a bunch of stuff for free. I actually downloaded a few already. And the way you would add them to your project is we can add it to, what was it, Demoland, I think? And it's going to download it and then import it to your project.
Last question. What does this have to do with Blender?
So with Blender, you can actually create these 3D objects. And then, I mean, either you can sell them on the marketplace or you just import them to your project. And Blender, if you don't know, is like a 3D creation tool. Like you create 3D objects. At least 3D is what I think. So the Wi-Fi is not the greatest, so maybe we'll skip that. Let's create this last thing. I think we're all getting a bit tired. So I'm just going to add like a simple hitbox that's very common in games. So let's actually use, we can add, so we have our blueprint, like I mentioned. But we're not going to use the key. But just to illustrate what this actually looks like. So remember, we have the event graph, construction script, and viewport. And if you wanted to add static meshes, sorry about that. So imagine if we had to make a key where when you go up to it, you can click on E, for instance, pick it up, and then change a variable maybe in the character or the player has key, and then you can open a door. And you would add first, you would need a static mesh. The difference between a static mesh, there's actually static mesh and skeletal mesh. Static meshes are for static objects that are not meant to be animated. And skeletal mesh has an actual skeleton. I can actually show it. So if we look at our third-person character that we're using, oh, sorry, not that one. We want to use the characters, mannequin, and these are all from the base product that I used. So let's look at the Manny doll, mannequin, if it will load up for me. So we have our asset here, and actually let's look at the skeleton of this guy. So you see, this is the difference between a skeletal mesh and a static mesh. A skeletal mesh will have its own skeleton, and this is why you can animate them. So you can make, when you like throw a sword, you can animate all of this. And when you pick up items, you can actually add sockets, is what you call them. I don't remember exactly how you did that. I think you just right-click. Create mesh sockets. And this is how you can actually hook some items. So imagine a game where you like put on clothes. You can put them on the skeleton or a hat or something. You use sockets in the skeleton to actually place them. But we were supposed to create a small hitbox and a little widget that says you won the game. So I'm actually just going to use the blueprint level. Actually, we need a collision box. So let's add that. It's this one, trigger box. I'm just going to place it here. And let's see if we can make it a bit bigger. And this one is really difficult to see, so I'm just going to put on wireframe. Makes it a little bit easier to see. Not as easy as I hoped. So essentially what this will do, this is our collision box. Let me go back to the lit environment. So when our character collides with this trigger box, we're just going to show a text. You made it out of the maze while the music is playing, hopefully. I'll change it to MacBook speakers. So with our trigger box selected, we'll go into our level. And then we'll actually add, there's an event. Let's see if we're there. So this is the first node we're going to start using. And this is an event that occurs. So events, in programming, events occur. You listen to events. So something can emit an event, and another recipient can listen to the event and do something. Let's see. Let me just remove this. And the overlap character that we want to use is the third-person character that we're actually using from Unreal Engine. And I don't know, let's see if I remember. We're going to create a widget. Widget is like something you place on the viewport for the user to see. It can be an interface, it can be something clickable. And we're actually going to add this to the viewport so you can actually see it. And we don't have a widget, so let's actually create one super quickly here in the content drawer. And you see there's so many things you can do. We're just going to create a widget blueprint. We can call the, I don't know, one. And I'm going to go a bit quickly on this. We're almost done. It's really hard to see here. And this is essentially the center of the viewport. So I'm just going to say, where do we have this text box? Yeah. And we're going to place this in the middle, anchor it to the side of the text, so this shows up at the middle of the screen. So we have something extremely simple. And in our demo land, we'll actually use this widget now. And hopefully this should be it. And we can compile and see if we have errors. We actually have an error. So, like I mentioned, you have the data pins, and the blue, I think, represents a reference. So a reference to another class, object, or something. If you have a look at the variables tab, you have booleans, floats, you have a bunch of things, you have functions. We can add all of this to a comment, for instance. Should print winning text. Yeah, well, let's do it quickly. So let's see if this actually works. Oh, by the way, let me go back to demo land. It's very exciting, right? I should have made a more difficult maze. couldn't get it. Let me just try quickly and then we're done. And I appreciate all this patience. So let's actually have a look at our box, trigger box. Let's open the blueprint level and let's see. No, not that one. No, it should. No, it should not be that one. So if this doesn't work, we'll call it quits. So essentially what this should mean is we have a few nodes, and we mentioned that nodes form like a node network, like a network graph. And the first one is, so when this event occurs, it's gonna do a certain action. This is the execution pin. It should cast to this third person character that we're using, or hopefully. And the consequence will be that we're gonna create this widget, and we're actually gonna append it to the viewport. Well, we'll see. And actually, let me start the character here. No. I think we're all tired, have had a lot. Maybe an appropriate name would be the worst game in the world. But I just want to finish off. I have 2 more slides, I think. Yeah. So while it's being used, I think we all know the Unreal Engine. I mean, we've heard a lot about it. It's pretty huge in the market. And just like relevant articles that I just looked up literally yesterday just to like, what are the new developments in Unreal Engine? Like The Witcher 1, if you've ever played it, was announced yesterday, in fact, that they're going to remake it in Unreal Engine 5. And actually upcoming AAA games. AAA means like these really huge like games for those not familiar with the term. Like The Witcher 4, Black Myth, Wukong, if you played any of these games, like are going to be made with Unreal Engine 5 and a ton more. And they've actually used some of the assets from Megascans in The Mandalorian, Westworld, and I think The Lion King as well. So the library that has these photorealistic images or objects were used in these shows. But when it comes to Unity, my interpretation is that it still is the king when it comes to 2D games in the mobile market. And that's it. But I've had my applause, so it's fine. But yeah, this video is pretty cool to watch. So a few artists had 90 days to create whatever they wanted in Unreal Engine 5. And it's pretty amazing what they've done. So thank you for attending, and if you have any more questions, ask away. Otherwise, have more beer, and thank you.